Okay, everyone, we are at it with our last lesson for this week, and we are on 11.2, areas of trapezoid, rhombi, and kites. So to start off, we have our definition of a trapezoid, which I believe we did learn in chapter 6, but again, that's just a quadrilateral with exactly one pair of parallel sides. Now, the trapezoid I have drawn here is going to be called an isosceles trapezoid, and that's because these two sides here that aren't the bases are in fact congruent. So I'm going to go ahead and label my two bases. Remember, that's your parallel sides on a trapezoid. So I'm going to say base 1, base 2. And then for the height of a trapezoid, the perpendicular distance between the bases. So again, just like a parallelogram, you're usually going to find it drawn here to draw or to make a right triangle. Okay, and for our formula for a trapezoid, that's going to be 1/2 times our height times the quantity of our two bases added together. Okay, and then finally for our area of a rhombus and kite, it's the same exact formula regardless of what polygon you have here. So it's going to be 1/2 times our diagonal 1 times our diagonal 2. We're going to go ahead and draw those in here. So it's your diagonals are, again, you should know this from previous units, but it's from your opposite corners to opposite corner. So here we have, we'll call this one our diagonal 1. And then here, this one we'll say is our diagonal 2. And then same idea over here for our rhombus, draw it in for your, from your opposite corners. So again, our horizontal one we can call diagonal 1, and our vertical one we can say was diagonal 2. So we're going to go ahead and do this first example here together, and yours should say find the perimeter here as well. So a new customer has a backyard in the shape of an isosceles trapezoid. And remember, all that means is that we know that these two sides here are congruent. So how many square feet of grass is needed to fill the entire backyard? Now, all that's asking for, since it says square feet, that indicates that we want our area. So we can see right here that it gives us our height is 32. And again, they just didn't label it on the inside of the trapezoid, so I'm going to go ahead and do that. And remember, for our area, we need our two base lengths and our height. So I'm going to start off by saying area is equal to 1/2 times our height, which we have, and then our base 1 plus our base 2. So we can see up at the top, our entire base at the top is 20.5, and then down here at the bottom, we can see that we have two sections of our base given to us as 5 feet each. And again, we're just going to bring down this 20.5 here. So our entire base length is just going to be 5 plus 5 plus 20.5, which is 30.5. So back up into our area formula, I'm going to add that 30.5 in there. And again, if we go ahead and enter this in our calculators, you can write or simplify this out before writing your final answer. But I'm okay if you jump right to it, and we should get 10,004 feet squared. Okay. Now for our perimeter, we have our two base lengths that we just used in our area, but we need to make sure to find those two congruent side lengths for the isosceles part, or for the part that makes this an isosceles trapezoid. So we're looking for these two diagonal lengths. And again, remember, we have right triangles technically inside of this trapezoid. So all we need to do to find these lengths is use our Pythag. So I'm going to go ahead and label it as x. And we have x as our hypotenuse of our right triangles. So x squared is going to equal to 5 squared plus 32 squared. And if we go ahead and simplify that a little bit, we get x squared is equal to 25 plus 1,024. And again, a little bit further here, we get 1,049 is equal to our x squared. So our x is going to equal the square root of that, which is 32.388. And again, if you just round to the hundredths, that's fine, but make sure you're at least rounding out to that. So for our perimeter, we now know that our two diagonal side lengths here, since it is an isosceles trapezoid, we know that they're both equal to that 32.388. So I'm going to go ahead and label that. And then again, our perimeter, we just have to add up all of our side lengths. So I'm going to do 2 times that 32.388 plus my entire base on the very bottom, which was that 30.5, and then plus my top line there, which was 20.5. And again, if we enter that in our calculators, we should get 115.776. And then again, make sure you have your units, so feet in this case. All right. So moving on down here, we have another isosceles trapezoid problem. I'm going to say that you do this one on your own and then check your answers with the key. Same with number 3 here, but be careful, you do not have an isosceles trapezoid anymore. You have, I guess you could call it an irregular trapezoid, but you are going to use Pythag in this one to solve, okay? But I'm going to let you guys try to do that one on your own. And we're going to do number 4 and 4 together and then number 5 together here. So for number 4, it says find the area of the kite, and it gives us all of these dimensions here to the left. Now remember, for your area of the kite, all you need are your two diagonal lengths. So we're looking for our BD length and our AC length. So this should be a really simple problem. So looking at our little chart to the left here, we see that AC is equal to 6 and our BD is equal to 5. So our total area for this one, oh, and I forgot my 1/2 here, I'm sorry, 1/2 times our two diagonals. So altogether there, that's going to be 1/2 times 30, which gives us 15. And again, we don't have any units, so make sure you write out units squared. Okay, so moving on to number 5 here, we have the area of a rhombus is 107 inches squared, and we need to find x. So the reason we're going to do this together, I forget if I already said it, but it's going to be because we're going to be actually using the quadratic formula, and I know it's been a while since you guys have used it. So we're going to start off, since we know our area is given to us, we know that that 107 is going to be equal to 1/2 times our two diagonals, so 2x plus 3 and x. So I'm going to go ahead and simplify this a little bit further, get rid of my 1/2, distribute my x into there. So I should get 214 is equal to 2x squared plus 3x. So remember, to solve for x, since we have an x squared, we have an x, and we have just a number, we want to get it in the form of ax squared plus bx plus c is equal to 0. So I'm going to go ahead and subtract 214 over on both sides, and I'll be left with 0 here on my left is equal to 2x squared plus 3x minus 214. And again, reason we're doing that is so we're in ax squared plus bx plus c is equal to 0. So for your quadratic form, remember that's when we have x is equal to negative b plus or minus the square root of b squared. Oh, Piper. Oh, hold on. Okay, sorry about that. My cat was getting into something. But anyways, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know you guys learned that song too, okay? But, oh, hold on. Okay, sorry again. There was a car horn going off and I don't know if you'd be able to hear it. So anyways, going back to this problem, we have x is equal to our negative b, in this case is going to be negative 3, plus or minus our square root of 3 squared minus 4 times 2 times negative 214. And again, that's all over 2 times our a, which is 2. So if you go ahead and simplify that out a little bit more, we're going to have x is equal to negative 3 plus or minus the square root of 1,721 all over 4. And then again, if we do the negative 3, Piper, stop that. If we do the negative 3 plus the square root all over 4, we're going to get 9.62. And then when we subtract it, we're going to go ahead and get negative 11.12. But remember, since one of our side lengths actually is just equal to x, we definitely can't have that negative number. So our final answer is just going to be that 9.62. All right, finally on to these last 3 questions here. Anytime you have questions like these 3, what you're going to want to do is set up an equation to represent the situation. So we'll do this first one together, and then you'll do the next 2 on your own. So we have one diagonal of a kite is 3 times as long as the other diagonal. So right away, I'm going to say to let diagonal 1 equal x, and diagonal 2 we'll say is 3x, so it's 3 times as long. So if the area of the kite is 330 centimeters squared, what are the lengths of the diagonals? So since we're dealing with a kite, we know that area formula is equal to 1/2 times your 2 diagonals. So I'm going to say 330 is equal to 1/2 times x times 3x. So to simplify that, I'm going to get rid of my half first by multiplying both sides by 2 and getting 660 is equal to, we're left with 3x squared here on the right. So to get x by itself, then we're going to divide both sides by 3, and we get 220 is equal to x squared. And then finally, take the square root, and we're going to get x is equal to 14.83. And a lot of people automatically stop here. If they think they've solved for x, they're good. But remember, it's asking what are the lengths of the diagonals. So your diagonal 1 is just going to be equal to that x we just found. And remember, we're in centimeters. And then your diagonal 2 is going to be 3 times that 14.83, which gives us 44.49. And again, make sure you label it with centimeters. So you guys go ahead and attempt the next 2 problems on your own. Check your answers with the key, and then please let me know if you have any questions at all.